The following content has been provided by RWTH Aachen University.
Good morning, everybody. Welcome back to DIS1, where we're rapidly approaching the end of this class and this semester. Today, we're going to talk about 10 golden rules, which are a collection of heuristics. So they are actually an example, a very simple example, of the kind of questions or criteria you could use in heuristic evaluation, which you will remember was one of the techniques that you can do without actually involving users, where you just go through an interface and check certain criteria. And then we're going to also talk a little bit about responsiveness in interactive systems. Before we do that, let's do a quick review of what we did last week. We talked about GOMS and KLM. And what does GOMS stand for? What are the big components of the model, of the sort of approach that we do there? Yeah, he's like counting it off on his fingers. Yeah, right. Yeah. So let's start with what do you got? Goals, operators, and something else, right? Methods and selection rules. Okay. So KLM in particular, the keystroke level model, basically a variant of GOMS that is simplified, right? That just does a simple sequence of interactions rather than having this tree that describes a task and the statistical probabilities of different operators being used by the user. So GOMS gets simplified in KLM. It gave us execution times for routine tasks, right? So we now know that pointing to something on the screen on a desktop takes roughly a second, right? So it's a much more rough estimate than what you get in Fitts law, of course. But you can use it if you don't know exactly, how big the distance is going to be, and if you just want an average to compare two different interfaces, for example. Important to remember that GOMS and also, of course, KLM really only work if you have somebody who knows the task, right? They're not figuring out the interface. They know how it works. They use it as fast as they cognitively can. Then we talked about information efficiency. We looked at the minimum information that is required for a task that the user needs to provide. And if you divide that by the actual information that the user supplies, then you can see how close that is to the optimum, right? And I think we talked about character efficiency as a variant of that, which is basically just the same principle applied to keyboard-based interfaces or keyboard and mouse-based interfaces, where you express the input essentially in characters being entered or displayed. The important thing here on this information efficiency, character efficiency, of course, is it's one lens we're giving you to look at an interface to possibly find out how good it could possibly be in respect to this efficiency, but it's not the only criterion, right? It's not, not necessarily the best interface with the highest information efficiency. We saw a couple examples, and we quickly identified other issues with these interfaces that need to be taken into account. Okay, so on to the 10 golden rules. I'm going to throw them up here just to give you an idea. This is what we're going to talk about today. These rules go from things that are pretty clear, like keeping the interface as simple as possible, all the way to things that maybe aren't quite so clear, like clear exits and closed dialogues. That's maybe a little bit of a confusing one. So we're going to look at each of these in turn, starting with, of course, keeping the interface simple. This is the most important rule. In fact, there is an example that I once saw in a usability book that said, here are my rules for user interface design. Rule number 1, keep it simple. Rule number 2 was something else. Rule number 3 was, remember to keep the interface simple. Right? So it's such an important thing and it's so easy to forget because we are in the middle of the project. We know everything about the software we're writing, about the domain, hopefully, that we're writing for. And so it's easy to have feature creep, settle in and pack your interface with more and more stuff and create more and more options because this is one user who wants this, and then you say, yeah, I can put it in. There's still space, right, for another button. And so it quickly happens that things get more complicated than they should be. We should be clear that everything you add to an interface makes it more complex to use, right? Makes it more challenging to use. And one of the things that I'm hoping you've realized in your own projects that you've done now is the very first attempt you take at a user interface design, when you just know what the topic is, usually has some of these problems, right? It usually is a little bit too convoluted. It's not the simplest, naive, most naive solution. Or it's not the simplest solution, sorry. Naive doesn't mean that it is simple. And this is a tricky quality, because once you see a UI that has been carefully, painfully designed to be as simple as possible, you're like, yeah, of course. Yeah, that's how you would do it, obviously, right? So it's hard to see the effort that's behind this. But I think you now have a little bit of an appreciation for how difficult it is. So if you want to amuse yourselves, go back in your notes to the UI you designed in one of our first classes. I think we did something for like a remote or something, right? So look at that and see, with all the tricks of the trade that you now know, all the methods of looking at things, look at that interface again and see how far from the ideal interface that was. There is, of course, the problem of feature creep is something that isn't just something that developers trigger, right? You will always have consumers asking for more features, right? That's often a request, and that comes up in reviews. Oh, but this, system has more features than this other competitor, so it must be better in some way. And so when this is being asked for, the important thing is, it doesn't mean that you can never add features to a system, obviously, but you have to make sure that your usability doesn't go down the drain. And there's this famous, one of the variants of the 80-20 rule says that if you look at 80% of the users over time when they use an interface, like a complex system, like, I don't know, Word, for example, they only end up using 20% of the features. Right? And then you got to ask yourself, how prominent are you going to make those other 80% of the features that get rarely used? How prominent do you make them in the interface to avoid cluttering it with things that most people will never want to see? It would be an honorable goal to say, we're releasing the next version of this app or whatever it is, and there's no new features, right? Nothing, no new features. We just clean things up. It's just easier to use. In fact, I've seen that happen. There was, many years ago, I was at the Worldwide Developers Conference, and Steve Jobs was up there, and he was announcing I don't know which version, 10.5 or something of Mac OS 10. And he said, he said, here's the number of new features in this version of macOS, and there was a big fat 0 on the screen. And everyone's like, what? And he said, yeah, we got so much cleanup to do under the hood. We have so many things that we need to straighten out in the UI. We're not adding any features. We're just making it more robust, more stable, and easier to use. But it happens rarely, right? If you are pressed for more features, then it usually means that you need to sort of put them out into maybe sub-dialogues, possibly, so that you don't overwhelm the main feature. Here's an example that I thought was actually pretty nice. Unfortunately, Apple has chosen to remove this. This is the Simple Finder. For the longest time, there was an option in the macOS Finder that you could turn on for a user account on the computer that said, use the Simple Finder. And it only had a single window. This was still in there in Mavericks, I think. From Catalina on, this feature was gone. There was no double clicking, only single clicking, right? There was no dragging of files, no aliases. There was only this one window of a fixed size. You couldn't move it. No toolbars. There were no folders, like you couldn't see any folders here and create them. If you wanted to create a folder, you had to actually do that from inside the application where you were saving a file. You could say, like, yeah, I want this to be in a new folder. You only had direct access to a very specific set of apps that were being defined in this setting. This was great. I set this up for my mom, right? Because she didn't use the computer much. She just wanted a few things to do, like writing letters, sending emails, browsing the web, and that was it. So we set it up this way, and she was just fine with it. And when that feature was removed, that's actually a problem, right? Then you suddenly have a much more complex interface that you need to deal with. So I thought this was a good idea. This is the universal icon for good idea that we're going to be using here. Here's an example of how it can go wrong, right? Take Blu-ray players. These used to be things where you put in a Blu-ray disc and then you play it, right? And everybody bought one to play their new content. But they're also a computer, right, in a way. And that's very tempting for the engineering team to say, oh, we could put, apps on this thing, and we could put a browser on this thing, and we could do, I don't know, a photo viewer on this thing. So, products tend to get overloaded with features because, I don't know, imagine what happened when the first Blu-ray players had been sold, and then, everybody who wanted one had one. And then you're like, okay, I don't know, you're Sony, like, what do we do now, right? How do we sell more Blu-ray players? And there's this, this urge to add something to it, which then ends up making it harder to use. Next up, one day I was shopping for a new alarm clock at like MediaMarkt or something, or Saturn, and I was shocked, right? All these things had like rows of identical looking tiny little buttons for setting the alarm and doing all sorts of things. And you're supposed to use these when you're like, half asleep in the evening, when you just want to set the alarm, right? I wanted to buy a new alarm clock, but I ended up not buying one. I built my own. Yeah, okay, that's a bit nerdy, but that's what I did. And this is an example that I wanted to show you of what I did there, because I thought through, okay, what do I really need from an alarm clock? For example, do I need an alarm that I can set with a precision of a single minute? No. There's probably some families with lots of kids that need this, like, okay, you got 3.5 minutes in the bathroom, go, right? But that wasn't the case in my situation. So I was fine with setting my alarm in like 15-minute increments, right? It's either I get up at 8 or I get up at 8:15. I don't need to, be woken up at 8:07 or something. And then secondly, I also realized that all the controls that were on these things for setting the alarm, or setting the time actually, were always like little buttons that you had to press, and then it would go one way or the other. And so they're really hard to figure out when you're not looking carefully. And so I put a knob on this thing instead that you could turn, and it has a nice clicky feeling, and every click advances the time by 50 minutes. You don't need to hold anything down for 3 seconds to start that. To get into some mode or something. It just works like that all the time. The other thing was I realized a lot of these alarm clocks made it actually tricky to see whether I'm currently looking at the clock or whether I'm looking at the alarm time right now. And then sometimes there's like a tiny little bell icon in the corner of the display. And I figured, well, we got enough space. I'm just going to show both at the same time, right? So that's got the current time on here, and it has the alarm beneath that. And there's a couple other stories about this thing, like what it plays back, et cetera. But just to show you, if you think about the task a little and then apply all these rules that we've learned of like natural mappings, et cetera, and mental models, you can actually sometimes simplify a product quite drastically.
How do you stop that alarm from
Oh, yeah. So if you want to stop it, that's actually a question that comes up often. This knob also is a push button, so you push it in, and that stops the alarm. I also found that I didn't need a snooze function. I don't live with a snooze function, so that was okay for me. But yeah, this is very specific, right? But it means you look at a use case in more detail, and then you figure out how you can simplify a UI. On the other end of the scale, maybe we have this, right? That's where somebody obviously, I don't know, had some drugs and then discovered the tab function in the interface builder, right? So went crazy. And this, of course, is way too much that you could possibly put into a UI, so not a good idea. All right, so that's keeping it simple. Speaking the user's language. It sounds easy, but it's really often overlooked. Speaking the user's language means in the first simplest example, if you have an application domain, let's say you're writing a software for architects, right? Then you want to use the words that they use to describe their work products, the things they use, the stuff they do. It's like they will talk about a drawing probably as an architect, right? They probably won't be talking about a file in their domain. So using those words appropriately makes much more sense to the users and then helps them feel comfortable in the interface and find their way around it. But it's not just about Word, it's about whole processes. For example, if you're doing this for, I don't know, a shop, then the shop will have this idea of an order, and the order will be some kind of process that happens, that comes in, that gets processed, that gets, ends up somewhere else. And so these workflows, etc., these work processes, these tasks, also all have names and concepts that users should find in the UI, right? That will make it so much easier for them to use it. So speaking the user's language, here's an example that I found that I thought was just hilarious. It's a remote for a pretty expensive stereo system, and looking at this, I wonder, right? So I understand what the touch buttons like tuner TV up there do. VCR, I understand. DSS, I'm less sure. Maybe it's like a shortcut to watch the latest show of Deutschland sucht den Superstar or something, I don't know. CD, DVD, again, is a little bit more obvious, but AD and ATT, I don't know what that does, right? Or, down there it has like ACH. Does that mean I can switch it to Austrian and Swiss programs or something? No idea, right? And so what you notice here is that this is not using words from the application domain. It has a couple other problems, right? So, for example, down here I have 3 buttons that are called like M, E, X, and S. I don't know, are these like clothes sizes for online shopping or something? I don't know. They're not labeled in a way that makes it very clear what they do. Pretty much the only one I can figure out easily is like the crossed out speaker symbol, because that probably toggles the mute on and off. Plus, then you also have like 2 rows of arrows that are completely looking the same without any labels. So not a great design, right? And of course, my favorite, it has a mode button, right? So that's another warning label for, ooh, that's going to be tricky to use. Years ago, when tablets really took off, we did a study for Connect, the magazine that evaluates mobile technology. And they asked us to look at how easily people can, how easy these things are to use. So we asked people to just do very basic things with these devices, and found some surprising things. So for example, and this is why I'm bringing this up here under Speak the User's Language, right? This was from a Samsung tablet, and it had a couple things on there that I didn't know what they would be doing, right? For example, what does All Share Play do? I don't really know, right? Or what does S suggest? What are these things? The names are a little confusing, and so that's a bad idea, right? And we get this oftentimes when the interface is being cobbled together by many different players with different interests, and that's a typical situation. You got the hardware vendor of the tablet, then you have the person, the application developers. Sometimes the UI comes from a different source than the hardware. Maybe then you even have the provider and telecom or whoever, Vodafone also puts their stuff on there. This can get very confusing. Here's another example where we can see that this idea of using words from the application domain was really pushed quite far. And this was a version of Apple Music. When you looked through the menu there, you'd find that it talks about music, songs, video, movies, playlists. The word files almost doesn't come up, right? It does come up in, for example, the file menu. Why? Well, that's where you get into the conflict. You can be domain specific in your wording, but there's also the rule of consistency to keep your interface consistent. We'll get to that later. And every application on macOS has to have a file menu. That's kind of a given rule, and certain things have to be under that file menu. Like the print function, for example, will always be there, or stuff like that. So this is where it then deviates from that. It also deviated in some other points from it. For example, when you actually wanted to get to the MP3 file on disk that music was storing for you, that was then called a file. But in other cases, it was just music, and etc. And this doesn't just apply to the menu bar, right? It also applies to things that you find in the main window, that you find in your online help, in dialogues, etc. So that's also about consistency. So good idea. Now moving on to rule number 3, consistency and predictability. I just said consistency is important. You saw some examples of them. Consistency is needed a lot across many levels, though. You don't just have it as saying, I want similar commands for similar situations, but you also want to have consistent terminology, like we just saw, like in menus, in help systems, in dialogues, etc., etc. And consistency goes beyond just words. It also is about visual consistency. I don't know if you've ever noticed this, but when you think about the visual design stuff, right, the PARC principles, we had some examples there where you saw what it looks like when things use 3 different line widths in a sketch or a drawing or a diagram or something. They're all slightly different, and it just looks, something's not right? So that's because it's not consistent. So using the same fonts, layout, color coding, upper, lower casing throughout the system is also an example of consistency. You'd be surprised how many people will look at a UI and say, this looks unprofessional. But if you ask them why, they can't really say why. And in the end, it's something like consistent capitalization of words in the UI. For example, there's very clear rules if you write an application, let's say from, I don't know, Mac OS or something, how you are supposed to capitalize your commands. When you put an ellipsis, 3 dots at the end of the command, there's exact rules when you do that and why you do that. And if you follow those, it just feels more consistent, and people can tell that something is designed carefully, even though they may not be able to point exactly at what it is. There are, of course, some exceptions for this. For example, you always provide clear text feedback when somebody presses the letter key on your keyboard. You always show that letter, but you don't in passwords, right? So when somebody's entering your password, you don't give that feedback. Or when you have something like a file to erase, then you may have, it may not immediately do what you're asking it to do. It may come back with a security question. So sometimes there are exceptions to this. Let's go back to a system that you guys know, the Xerox Star, which was from, prize question, when did the Xerox Star come out? I know it's like weeks ago that you learned this, so. Plus you wrote a midterm about it, so it's probably erased from memory, but give me a decade. Very close. The Alto was in the 70s. That was 73. The Star was just scratched the 80s. So 81 is when the Star came out. But yeah, it's an old system, right? Obviously. And you may remember this was the one that built on the ideas of the Alto. And Alto and Star introduced basically the WIMP interface, right? Windows icons, menus, pointers. And you may remember from the video they had the same physical buttons to copy, whether it was copying a file or copy a word in a text editor or copy an object in a graphics program or whatever. Right? And that is actually, to a certain degree, still true today, except now you have Control-X, Control-V, Control-C. So Control-C is sort of your universal copy command. A little less visible, right, for a newcomer. It's easier to see a button that says copy than to remember that, or to look up in the menu that you have to use this shortcut. But that's one of the prices we've paid for standardized keyboards. So good idea, right? Good idea because that's consistency with buttons, bringing the same functionality to many different applications and scenarios. You can also reach consistency, or let's put it that way, it's actually easier to reach consistency if you happen to be in a situation where you can do what I'd like to call vertical design. Meaning you are the company or institution or whatever that is responsible for the hardware, the operating system, the GUI, the user interface toolkit, the key applications on this thing, then it's actually pretty easy to be consistent. And we see this not just with Apple's iPhones and stuff like this, but we also saw this, for example, with these navigation systems, right, that TomTom built, because they also designed their own hardware, they wrote the OS, they designed the UI, and there's pretty much only one app running on this thing, really. So they had everything under one roof. So imagine you're the guy or the girl that's designing the alarm snooze logic in the alarm clock app on the iPhone. You can literally like walk over a couple floors and talk to the person that is designing that side switch on the hardware of the iPhone. Say like, hey, wouldn't it be good if we could actually use that side switch also to always disable or enable the alarm when it's being toggled? You have this connection across these levels of abstraction, right? This is really hard if, while you're designing an app, you have no idea what hardware you're really running onto, right? You're really running on. So many systems, for example, Android phones have that challenge, right? Lots of different manufacturers, even several variants of operating systems, and it's just harder to come to a really consistent application experience that way. Microsoft has faced the same thing. One of the reasons why they also brought out their own hardware, right? Because there they can control the whole stack and make it really work together much more smoothly. All right, so that's consistency through vertical design, one example. But this guideline was called consistency and predictability. And let me talk about predictability just a little. There's a lovely principle. I really think it nails it. That says whenever you have to make a design decision in your interface, think about the options that you have, and then pick the one that will surprise the user the least. Now, this is not when you're writing, obviously, like in a text adventure game or something, right? Yeah, sometimes you want to surprise people, but usually we're not trying to, be surprised by a computer when we're working with them. They should be doing what we expect them to do, right? And this is why I'm bundling this with consistency. So try to design systems so they always surprise the user the least, because surprise usually in most of these situations will lead to people being irritated, frustrated, confused about what the system is doing. So that means you don't do unexpected things, right? So you don't suddenly pop up a dialogue that says, ooh, your battery is now fully charged. But you also don't make actions unexpectedly difficult. For example, if the user wants to print something in duplex, that shouldn't be unexpectedly difficult to find because it's such a frequent request when people are printing. This idea of being predictable as a software has to do with the fact that people like to be in control, right? They like to be in control of what their technology is doing as they're using it. And this is what you're trying to provide here. You're trying to provide people with a solid feel of control over what the tool in their hand is doing for them. This is especially true when you're dealing with advanced users that are experts, right? They will not tolerate systems that do stuff that doesn't match their expectations. So usually people want to initiate actions on the system, and the system then responds, right? That's the traditional way. Now, I should say that we are currently entering an age in which this tool idea of computing technology is being supplanted or extended by this other idea of systems being agents or being well, not people, but being something that is, that I'm talking to, that I'm conversing with. I'm talking about all the AI-infused systems, voice assistants, etc. These things are beginning to develop more of their own initiative, but that's a different design paradigm to apply that has its own problems. So in many cases, you're writing applications that are simply supposed to work as a tool, right? So the principle of least surprise means, while I'm giving this talk here right now to you guys, I don't want a dialog to pop up and say, your battery is fully charged, right? Because that would be distracting to me. If it's actually on the big screen, it would be distracting to everybody. And it reminds me a little bit of, like a little kid that says like, oh, attention, I want your attention right now. I'm so proud I charged your battery fully. That doesn't make sense, right? What's happening here? Well, the system is creating this message, and it isn't aware of the situation, of the social context in which it is being used right now, right? It has no idea. It maybe could, right? The computer could check my calendar and know that I'm giving a class and then decide to mute those kinds of notifications during that class. That would be a little bit smarter, but who knows? Maybe that our class gets moved sometimes, and then it gets a little trickier. So oftentimes systems are how should I say this? They're trying to be too smart for what they actually know. Right? So a lot of smart technology is more like smart-ass technology. It tries to be smart, but it actually doesn't really have a good idea of what's going on, and then is making these assumptions. This reminds me of Clippy. Does anybody here in the room still know of Clippy? Does that? Wow, that is, I mean, I don't think they're proud of this, but it's impressive that like decades later people still know of this, because it was so annoying. What was going on, and I met the guy who was the lead behind the early sort of artificial intelligence that went into designing Clippy, and it was actually not a bad design, but it then was kind of botched when it was built into products at Microsoft. Because the original system was trying to be pretty clever about when it popped up and disturbed you. And then in productizing it, those rules got simplified a lot, and developers got simple access to say, I want to pop up Clippy now. And that was one of the mistakes, right? It shouldn't have worked that way. They should have just been able to give hints sort of to Clippy whether it should pop up or not, and the AI should decide themselves whether to pop up or not. But what it did was, it would pop up while you were, when it thought it had deducted that you were writing a letter, and then it would, offer you help. And the problem with that, of course, was that it would not just go away. You couldn't just remove it. It was actually pretty obnoxious. So all these examples are showing that the system is then trying to be a little bit more like a person in a way, trying to take over initiative. But if I have my system trying to be like a person, then I think I'd prefer something like this, right? I prefer something like, a butler standing at the side, and then if my battery is fully charged, and once my lecture is wrapped up and I'm not on the big stage anymore, that that would come over like, excuse me, Professor Borch, yeah, battery is now full, by the way. That would be okay, right? But unfortunately, our systems aren't that smart. Let me come back to this PowerPoint assistant. I want to show you this because I captured this from my friend's screen back at the time. Let's assume you're using PowerPoint, right, on a Mac in the 90s, and Clippy is there. On the Mac, by the way, Clippy was this tiny little Mac Plus, so it was like super cute, like with legs and all. And you would click on something that you couldn't edit on the slide, right? You could only edit it on the master slide. It's a pretty standard problem. So Microsoft thought, we're going to help people figure that out. So if you'd clicked on something that was only editable on the master slide, this appeared. Now the problem with that was, you might think, oh yeah, I just missed, maybe you just clicked off by a pixel, and you just want to continue working. You know that this is on the master slide, and yes. So you think, okay, I'm going to make this thing go away by, closing this button here or hitting OK. But no, if you tried that, another thing would pop up. It would then actually say, no, sorry, you must click an option before you can close the assistant. You had to pick one of these two things, and then you had to first close this dialog, right, this message, and then you had to go back to this screen in order to do this. At which point, of course, people were like, how do I uninstall Clippy, right? So that was one of the most frequent searches on the internet back then, like, how do I get rid of Clippy? And then once it was removed, one of the most frequent searches, how do I get back Clippy? Yeah, people are weird. But anyway, not a good idea. And so this is an example of a system that becomes very self-initiative. And but doesn't really have a clue what it's doing. It's like blundering around like, a kid that doesn't understand social rules of when you speak and when you let other people speak and when you don't disturb them, etc. And it just barges in there. It's like, have you ever been in your car with, a friend and you're having a conversation and all of a sudden the nav set in the middle of your sentence, your TomTom or GPS goes like, by the way, in 300 kilometers, turn right. And you're like, thank you. That was really nice. No sane person would do that, right? But systems do it, and so that shows that they are not smart. They don't understand enough of their environment, and then they try to make big assumptions about what they can and cannot do. Closely linked to that is, I should get out a soapbox now because I'm going to get on one, timeouts, right? Timeouts are like the worst. Following situation, that's why I'm showing a car radio here. You are coming down, like Adalbertstraße, let's say, right, here in Aachen. And so you're approaching that sharp turn to get you onto the ring, right, in your car. So you have to take a sharp left. But you're also looking for your favorite country music radio station, okay? Just go with it right now. So you've hit this like station search button, okay? She's like, yeah, I don't like country music. This isn't making sense. You can pick something else. But you hit the station search. You know the station search button that goes through every station and plays it for like 5 seconds or something, and you get 5 seconds to hit a button to stop there. And if you don't, then it goes on to the next station. That was a thing on radios a lot when before digital radio took over. So this thing is leaving through, going through all these stations, and just as you approach the intersection, your country music station comes up. So 2 options. You can either risk your life, take that turn one-handed, right, and hit the button within the next 5 seconds to stop the station search at your station that you wanted to hear. Or you can let it pass by and take the turn safely, but then you'll be listening to all the other stations until it comes around again. And probably the second time around, because the radio is smart, it will play even more stations, because now it's also playing you the weaker radio stations the second time around, because obviously the first time around it didn't find it, right? Because you didn't press that button within the 5 seconds that it gave you. So that's a terrible design, right? And why is it terrible? Because it's a timeout, right? In this case, these 5 seconds for each station is way too long if it's not the station you're looking for, and it can be way too short if it is the station you're looking for, right? So not a good idea. Another example, and this is, okay, I'm going to do another sort of, generation check here. Has anybody ever typed on a phone where you had to press buttons multiple times to get different? Okay, you're still with me, good. So what was the most annoying thing typing messages on these things that could relate to timeouts? Yeah?
When you want to type a letter that is on the same button.
Exactly, right? If you wanted to type 2 letter T's, you press T and then you gotta wait and then until the timeout is over and you press the T button again, right? If you didn't, you get, the T turns into a U and you're like, no, that's not what I wanted. And you know what some people did? Or maybe, did you have a strategy how to deal with that? Because somebody told me, and then I must say, yeah, you're right, that's what I did too. It's completely insane, but that's what I did.
Maybe space, delete, and do it again.
Exactly. So a lot of people would actually hit the letter T, hit any other key just to end the freaking timeout, delete that other key again, and then hit the second one, just to get out of this, having to wait. Because it's so interruptive to your flow of interaction. Isn't that amazing? And what's the problem? Timeout, right? So the timeout is too short when you are trying to see what options there are, like how do I get to whatever, a special character, then it's too quick, right? So you need to keep pressing it so that the thing doesn't time out on you. Or it is too long because you're waiting for, because I just want to type another T and I just need this thing to time out. So not a good idea. Another example, just to show you, Apple can really mess things up too. So here's on your home screen, before you've unlocked your phone, you can get to your camera, with a quick shortcut. Do you tap that? Do you swipe it? No, you actually have to click and hold it with a timeout before it unlocks. It's not long, but it's there. And it's enough that I find myself like 30% of the time, it doesn't work the first time, and I need to go back and hit it again. So timeouts are not a good idea. And maybe this is another example, closing this up. This is an emergency exit. In the US, you've got oftentimes emergency exit where you push this bar, and then it opens to the outside, which is, it's a good idea, right? It's not a door I need to pull. That's good with an emergency exit because I got 50 people behind me that are going to slam into me if I need to pull the door. So that's okay. I can also see where I need to push, so that's a good design. It's not a Norman door, as people like to call them. But it has a problem, right? You need to press the bar for 3 seconds, and then the door lock will release in 15 seconds, by which time probably you're half fried because there's that fire behind you. So why did they put this there? Probably some security consideration that people shouldn't escape through this door after stealing some stuff in the store or something. But in a real emergency situation, I don't think anybody appreciates waiting for a total of 18 seconds when they are trying to flee a building that's on fire. Right? So not a good idea. The first rules are a little bit more extensive, and the other ones are now going to be a little more compact. The next one we're going to talk about is rule number 4, which is providing feedback and being responsive. Providing feedback means that if you recall the 7 stages of action, we know that if we provide complete and continuous feedback on what the user is doing, then they actually, this actually helps them to bridge the gulf of evaluation, right? The one on the right-hand side going up, right? Where you're trying to, the user's trying to figure out what's going on, whether what they did was actually successful, et cetera, et cetera. You need to, of course, in some way provide feedback for every user, right? So let's say I press a key on a keyboard in like Word. Yeah, the letter pops up, right? I don't need, of course, a dialog popping up. You press the letter O, and then confirm with OK. That would be way too much. So small actions need small feedback, but they need some feedback. And if you have long actions or infrequent ones or important ones, then the feedback can be more pronounced, can be bigger and more noticeable. Like saving a file or maybe even deleting a file might require some significant feedback so that users are really aware of what they just did. If they delete something by accident by hitting, I don't know, Command backspace on the Mac, and you throw a file in the trash, at least you get the sound effect of, oh, something just went to the trash, and you're like, oh, I threw something away. Right? So that's good to know. But you wouldn't want that every time you do a small thing on the computer. And feedback is one of those things where we can really see why GUIs were so successful, why graphical user interfaces were so much more successful than text interfaces. Because imagine the situation: you've got a file in a folder on a hard drive, and you have a text command line based, like Unix style, DOS style interface to work with it. When do you actually see that file? Well, the moment you enter dir or ls, right, and you look at that content, or you look at the fact that a file is there, and then you do something like you move it somewhere else. But to see whether that actually worked, you need to go through that new directory, change directory, blah, 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 and then dir again, and look whether that happened. So you don't actually have a visual, continuous representation of the thing, of the file, to look at, right? It's not there. Very different in a GUI. In a GUI, the file is that icon in a folder. And I take it, I drag it somewhere, I put it somewhere else, and all the time I have a visual representation of that thing, and that's way easier to provide feedback with, right? I can show whether files are moving, I can show whether they're being opened, I can animate things on them, I can invert them when I'm selecting them. The whole object action thing, like selecting something and then acting on it, really only works with graphical user interfaces. So this whole concept of direct manipulation, as we call it, really only works in a GUI. Feedback is so important because users can be very frustrated if they don't understand where they are. You've been in this situation probably, maybe on a website or in an application. You're like, what's the current state? Like, where am I in this app? What is it currently expecting of me, right? And if you're at that kind of confusion, you often end up there because the feedback wasn't appropriate, right? So that's why it's usually a good idea to have this kind of feedback of where is the user and what's the system doing right now? Is it still saving, or is it, did it crash? Is there a problem, or is it just taking a little longer? What is going on? We will talk more about responsiveness later, but for now I want to show you a couple examples. I love this dialog. This is from Windows 2000, and lots of things are wrong with this picture. Right? The first problem, of course, is, okay, I'm copying something from installer to installer. Not very helpful, right? I don't know which way this is actually going or where these installers actually are. Then the second thing that's not good at this thing is the progress bar. Why? Because these progress bars often aren't actually showing you the full linear progress, right? Have you ever seen a progress bar that goes up to like 99% and then it stops and does things for like inordinate amounts of times? Isn't that annoying, right? That's because whoever programmed this didn't understand what a progress bar is for. Progress bars only make sense if they advance linearly over time with the progression of the task. And yes, that's a difficult programming problem. It's not always easy, and sometimes it's actually impossible to predict how long something is going to take. But then the system shouldn't lie, right? Then it should be honest about, I don't know yet, and I'm figuring it out. Did you have a comment? Yeah.
Yeah, because what I always heard about progress bars is that even if they're not accurate, it's still better to have them to give the user some feedback, because otherwise we will, like if the progress bar, for example, doesn't move or we don't see anything and it takes a little longer, we automatically assume something went wrong. We try to restart it, and so even if it's not doing going exactly linearly, we still see that it's doing something.
Yeah, and I would agree that in this case, what you're providing is an activity indicator, right? So you're telling people, yes, I'm still working on this thing and I'm slowly getting where I want to get. But the moment you show this kind of bar that says, over there is the end and this is where we start, the assumption is, of course, that when you're in the middle, you're halfway done, right? And the only useful estimate that people want to hear is time. And they're not interested whether I'm copying 5 gigabytes, and the first 4 of these are super fast, and the last one takes forever because it's a million small files, right? They are interested in the overall time. So yes, it's always better to provide some feedback than no feedback, but a progress bar that is misleading is quite a problem, right? People get into all kinds of emotional states because of progress bars that don't wrap up linearly. Yeah.
I think now, I've seen on many websites, I think it's all with some good UX writing when they, when there's going like this, and then they text changes from something like, hey, can on a bit more, don't bring the page, and then it says maybe something funny or whatever. So the process is still going, but you don't have the bar.
Yeah.
It kind of gives you constantly different,
It shows you something. Yeah, right. So that's one way of doing it. So that's what I meant with being honest, right? If I don't know how long the process is going to take, I shouldn't say something about a time that it's going to take, right? That doesn't make sense. I should say, I'm still calculating how long it's going to take. And yes, you can, depending on what kind of application it is, you can make that wait time interesting for people. You can try to entertain them with this, but that's not providing an idea of how far we are along in the task, right? That's one of the challenges here. Yeah, go ahead.
One more thing, yeah, because I remember when I myself was copying a lot of files, not recently, but when computers were even a little slower, and I wanted to know an estimate. Can I go away, come back in 15 minutes, and stuff like that. And so for that, I need some sort of time estimate.
Yes, absolutely. And yeah, I'm not saying time estimates are a bad idea. They should be there the moment they can be done with some idea of precision, right? So there's a couple more things that I wanted to mention with this. This is ridiculous for several reasons. First of all, Does anybody believe this 55? No. She's like, nah, come on. So it's not going to be 55 seconds in the end, right? We don't trust it really. So it's probably going to be off. But the second thing is, do we really care? No, right? It's exactly as you said. Can I go away? Can I make myself a frozen pizza? Or is it enough to at least make myself a cup of tea? This is the kind of stuff we're interested in. So we want to know, is it going to be about a minute, or is it going to be about 2 minutes, or 5, or 10? So we want to know these, rough estimates are perfectly fine for us. Because first of all, they're more honest, because the system is not going to nail it down to the second probably. And secondly, we don't care about that kind of level of precision. It's a typical computer precision that is unnecessary. Not only is it wrong, but it's also unnecessary. So, and that has actually changed with lots of operating systems these days, provide feedback here that is more of the order of, yeah, this is going to be about a minute. And then yeah, it's not going to be exactly 60 seconds, but I get an idea. I can go off, do something else, or maybe I should stay. It's okay to stay because it's not going to be much longer than a minute. If these things do their estimates, then they they're off. The general idea is that you should rather estimate on the conservative side. So rather give people an estimate that's a little longer than it's actually going to take, and make that shorter after a while, rather than the opposite. Simply because if people see, okay, going to take 3 hours, they're going to make arrangements for that kind of thing. And then if it's over before that, who cares? But if you say 50 minutes and like, okay, I'm going to finish that, and then I'm going to go run and catch the bus, and then it gets to 20 and 25 minutes, then you're messing with people's plans, right? So that's why the estimate should be this way. But there's something else that's interesting about this one. Similar to what you said about like entertaining people with funny messages on the way, these things also had this flying piece of paper going from A to B, right? Did that mean anything? No, it didn't. You would think that if you're copying documents, for each document there's one flying piece of paper from left to right. No. This was just an animation showing a paper flying from left to right. And as you know, it was magical because the moment the paper arrived on the right-hand side, it reappeared on the left, right? It was just an endless, brainless animation. So this is not actually telling me about progress, right? Sometimes there were good ways of doing this. For example, if a printer had to print 8 pages, you would see 8 pages being fed into the printer, and that's actually useful, right? But if it's just a brainless animation, I can see how Bill Gates probably walked around and grabbed some, pimply intern and said, make some kind of animation there. It doesn't really need to mean anything, just so that stuff is moving on the screen so people are entertained. And that's a waste of an opportunity, right? Because you can make that animation say something interesting, have some semantics, and tell the user something about what's going on, rather than just being an animated carousel. What's worse, when the dialogue was done, it's not unlikely that this animation actually ended exactly like this. Right? The last thing the user would see is one document page in the middle of between these two folders in midair, and then the dialogue goes away. And I could see, again, my parents go like, what about that last page? Where did it go? Is it, did it fall under the computer or something? What happened? So because we are suggesting something. Again, remember, you're magicians, right? You're creating an illusion. People are going to think that there's some meaning to these little things flying from left to right. And if there isn't, then that's actually a misleading interface. So not a good idea. In a variety of different ways, this is not a good idea. Quick quiz here. Let's say you're selecting a menu, just picking a menu item from your favorite operating system. I don't care, Mac, Windows, Linux. What happens exactly when you click on that menu item? What happens at that moment? Not interested about the big thing, but the small things, yeah? It highlights itself. So it actually highlights itself already as you kind of cross over it, right? There's some kind of highlight telling you you've now picked this menu, but when you click it and then let go, the moment you release the mouse, something more happens. There's more than just a highlight, yeah? It disappears, yes. Sometimes it disappears at once. Sometimes it fades away over a very short fraction of time with a little animation these days. There's something else going on?
And the mouse icon changes, the loading symbol maybe?
It might, but that will depend on what you picked, right? If it's just, I don't know, undo or something, or open the find box, then it won't usually change. Yeah, so sometimes it changes if the menu means that you're entering a different kind of mode in the app. But there's even something else going on. It's related to the highlighting. Yeah, it's perfectly normal that you don't realize or not consciously, but actually. Look at this. This is an example from macOS. What happens when you click this? So this is the highlighting that you mentioned. Do you see what happened? It blinked once, right? So this is what's going on, right? You select it, and then it goes away again, and then it gets selected again, and then the menu fades away. Actually, in classic macOS, you were able to adjust the number of times it would blink. So if you wanted it to be more pronounced, you could make it blink like 3 times before it goes away. And if you wanted it to be a little snappier, you could select it to be only like 1, for example. Or you could even turn it off, which actually feels really weird. Here's an example of, this is a CD installed, like, live version of GNOME. And if you look at this, you will see that the menu just disappears. So you pick something, and it's gone. And when you use this yourself, it will feel like you're walking on ice, because the moment it goes away, you don't get a tiny confirmation that, yes, you selected the right menu. Don't worry, you didn't slip off the menu at the last moment. It's everything is good, right? You're missing that kind of information. And so this can be really confusing, right? This just going away from one moment to the next. No animation, no highlighting, no confirmation, no feedback, really, right? So I'm just saying these are the small things that are designed into good user interfaces that will make you feel more at home in the interface, and will give you a feedback that you picked the right choice. But it's not just about visual. Haptic feedback, for example, is also super important. And haptic feedback, you might think of like your phone buzzing and shaking in your pocket when you get a message. That's one kind of haptic feedback. But there's another thing about haptics that's pretty important, and that is the haptics that I get by just putting my fingers on this keyboard. I can actually feel the keys, and I can type without looking. There's tiny little bumps on 2 keys to orient myself if I get lost. Try that on a smartphone. It's kind of a challenge, right? On a glass surface, you don't feel the keys. And so don't underestimate how important it is, or how much benefit people can get out of a haptic way of, I don't know what to call this, a priori feedback. Like it's feed forward almost, where you can actually orient yourself and know that you're about to hit the right key before you do it. So that's one big argument for physical buttons and keys in certain situations. For example, all the touchscreens that are currently being mounted in cars are, wow, kind of a dangerous idea if you think about it, because you can't really operate these without looking at them, right? So you're taking your eyes off the road. Years ago, we built a system that had like 240 electromagnets under a table, and you could glue a little electromagnet to your finger, and then you could actually feel haptic feedback being generated by that table. So haptic feedback is an important one. All right, moving on to number 5, minimizing memory load. We know from the CMN model and the things we talked about with chunks, etc., that people can only remember very limited amount of information in their short-term memory. Right? And because that is true, we're at like maybe 4 plus or minus 1 chunks is what the latest numbers are saying, right? Back then we used to say 7 plus or minus 2. That means you need to avoid situations where information that was shown a little while before suddenly needs to be recalled. And I don't know, maybe you've been in this situation, like page 1 of a sign-up sheet asks you to pick a username or something, and then page 3 of the sign-up sheet 2 minutes later asks you to enter that username again. And you're like, well, I just entered it. The system should know it, right? Why do I need to enter it again? So these things should be avoided. Users shouldn't have to type in anything twice. It's unnecessary. The other thing you can do to help people reduce memory load is to use gestalt laws. Right? If you cluster your UI well, if you use something like the law of proximity, or the law of closed shape, etc., or similarity. Then you can help people to quickly make sense of a UI, waste less memory cycles and less memory capacity on understanding and memorizing the interface, because they will be easily orienting themselves in the UI and finding the right things to hit and to push. This is often supported in systems with help pages. So, for example, every now and then I need to enter an ohm sign, okay? Whenever I'm like fiddling with some electronics, I need to write down a resistance, so I need the ohm sign, like the little, the capital omega. I don't clearly remember what key combination that is on my Mac keyboard. There is a key combination to get that ohm sign, but I don't remember it. So what do? I go to the little menu option, show me my keyboard, and then a keyword pops up on the screen. I can push some of the modifier keys, like control or option key or something like that. And I can see what special symbols are on which key. And I'm like, oh yeah, it was, whatever, option Z or something. So this is super helpful, and that's helping minimize users' memory load too, because you don't ask people to remember these things, you give them the information right there. Keyboard shortcuts in Keynote, right? In Keynote you can pop up a list of these things. I think we have a picture of that. So this is really a useful thing to put in your applications. And again, it's easier to minimize memory load when you have a graphical user interface than if you have a command-based interface. It's obvious, right? If I put you in front of a Linux terminal and you haven't used it for a few years, you're like, wait, there was a command to list the contents of a directory, but what was it again, right? Because it's not there. You need to have it in your head. Whereas a GUI, yeah, you can explore. You see all the commands laid out before you with menus, etc., and you just pick and choose. So here's the keyboard view I was talking about. That pops up, that you can pop up anytime you're anywhere in macOS, and there's the omega symbol, right? So I'm holding down the Alt key right now, and that shows the special symbols on each key. And if I know the keyboard shortcut, I can use it, right? But if I don't remember it, I can look this up here. Here's this example from Keynote. And that's one of the things in the help menu from Keynote, the PowerPoint sort of alternative that you get on macOS. It has not just a regular help or what's new, but it also has an entry with keyword shortcuts. If you open it up, you get all these interesting things. It even explains to you what symbol means what. And you can go through and say, like, oh, OK, I didn't know there was a keyword shortcut to blank the screen, for example, right? So that's nice, right? I don't need to go to some like faraway documentation to find these things. It's right there in the menu. That's how you help people minimize memory load. Number 6, errors. Now, we talked about errors, right, at length. We talked about mistakes and slips, etc., these different kinds of errors that people make. Whenever people make mistakes, it leads to stress. There's a lot of research about, like, how can the computer detect the emotional state of the user when they're using an application? I can tell you a very simple trick. Whenever your application is popping up an error dialog, when your logic tells your app to pop up an error dialog, you know the user is annoyed. That's very simple, right? Nobody likes error messages. So errors always lead to stress. So what you need to do when you provide error messages and in the continuing interaction after that, you need to help people to recover from them. You need to give simple instructions because people made a mistake, so maybe they're not quite firm in using the system. They need to be constructive, telling the user what to do to get around the error, to resolve it. So helpful and comfortable, right, in a way that doesn't make the user feel bad or even worse than they already feel because the error popped up. Remember, they're stressed out, they're insecure, something went wrong, right? They're not in their happy place. Another good rule for your application design is to not change state through these kinds of errors that cannot be recovered. So if people make a mistake, there should be a way to undo it, right? There should be an undo function to recover from this. Or, in extreme cases, don't make irrevocable changes, right? That's why we have the wastebasket, right? The paper trash can, where we can throw stuff away on the desktop and we can fish it back out later if we made a mistake. Of course, the best design is so that you don't make mistakes in the first place. What does that mean? Well, if you're asking people to type in a date, offer them an option to pick it from a calendar instead, right? So that they can't make any typing mistakes. You may still want to consider offering them a way to type it in by hand if they choose to, because it's much faster. That's a shortcut for experts, rule number 9. But usually it's a good idea to avoid this. If people need to enter a number, don't let them enter characters, right? So just reject that input right there so that they don't make the mistake to enter something that doesn't parse later on. It's a good exercise to look at games, especially arcade games, where you will not find error messages in these things. Of course, your character can die a horrible death in your game, but usually you can't make any mistakes in the UI, like oh, you entered a wrong character in your high score name, right? That doesn't happen, right? These things are so streamlined for the interaction to be enjoyable and error-free that there are usually no error messages at all. Another thing, and that's an interesting one, is when people enter file names. Every operating system has its kind of quirks, right? What kind of characters you can't use in a file name. It's different between operating systems, and sometimes it's a little hard to know exactly which rules to apply in which situation. So one way to approach that is to just correct mistakes. When people enter a file name, just turn that letter into something that actually is legal. Quick discussion is that what other rule are you breaking or are you pushing against when you do an automatic correction? For example, on the Mac, you can't enter a slash character, you can't enter a colon because that's the divider for file names. And if you do that, then it gets replaced with something else, I think with a minus sign. Is that a good idea, or what could be an issue with that?
I think the two things that would come up is one, there's no feedback it happened, and two, it's not predictable anymore. You don't know that it happened. Right, yeah. So the feedback is an issue if you do that after the name has been entered and then the file gets generated and you then replace it all at once. And you do it as the user is typing, then they do get the feedback. But you are right, then it's surprising, right? I hit the colon and I'm seeing a minus sign, like what's going on? I'm seeing a hyphen. And you might go back like, did I mistype that? And no, it changes it. If that happens without any other comment, people could be quite confused. So you're avoiding the error of a wrong file name, but you're creating a little bit of a less predictable sort of, not following the principle of least surprise behavior here. Yeah, Katar.
It could even lead to more errors. For example, if you are programming something and then you create a folder and it has a illegal character, then you change it and then the program breaks.
Okay, because the program was assuming a different name in there. Yeah, that's a good point. Yeah, that name might actually be something you're using somewhere else. Yeah, absolutely. So here are some examples. This is a bad example from Mac OS X these days. They actually made it worse. It used to be, like I said, it just automatically replaced colons with hyphens. And now if you type something in like A:B, you get, it's almost like a text adventure. Like, the name A:B cannot be used. Try using a name with fewer characters or with no punctuation mark. Like, how mystical can you be in your error message, right? That's not helpful. They know exactly what went wrong, so why aren't they telling us, right? Why aren't they saying, well, can't use a colon in a file name, use something else there. Here are the characters you can use, right? Or here are the 5 characters you cannot use, something like that. So that's this terrible, terrible message. Shouldn't be done that way. So undo, we're still in the rule number 6 with the errors. Undo is, of course, a really, really powerful way to handle this, right? You want to offer undo, but you want to not just offer a single-step undo, but as many actions as possible, like being able to go back in history. We've all used this, haven't we? Like gone back, like, oh my God, yeah, I messed this up, 5 steps ago. Hopefully, I can retrace my steps. what that also does is a nice side effect. If you give people a system that supports good undo, they will actually start exploring things. They will try out functions. Like if you're a Photoshop user and you know there's a good command history, you're going to try out that weird filter and see how it works, because you know you can go back. Right? So it's a good thing to encourage people. Ideally, you don't just have multiple steps of undo, but you also have it at multiple levels. So for example, in the command history of Photoshop, you can go back, but then you can store versions of the file as well, so that you have another layer of sort of undoability, basically. And then maybe your backup system even is storing things on yet another level. So this is a short video that shows you how powerful Photoshop's undo is. It's so powerful that it begins to become complicated. Photoshop, you will see in this video, users undoing actions they've done, and then they also can delete the action history. So they can delete the action history, and that deletion of the action history can actually be undone as well. Yeah, and then your brain goes like, oh, what am I doing, right? But for people who are working with graphics, this is often used quite a lot, right? So here are the actions that were being done one after the other to do this, and now we're seeing, you can jump between these. You can delete one thing in there, and it's gone. And now you can actually undo that change of the state. So Photoshop has really gone all in on the amount of undoability. So it's the gold standard of supporting that. This rule is a little confusing, maybe. Design clear exits and close dialogues. What it means is that when people are using a dialogue-based system, they often ask themselves three kinds of questions. The first question is, where am I? Have you ever been on a complex website, maybe shopping or like looking something up, and you're like, wait a minute, where am I on this site right now? What is it doing right now? Right? That's a very frequent situation. The second question people are often asking themselves, all the time really, is what can I do here? Right? What are the available actions? We know this from the 7 stages of action, right? And we're trying to figure out the available actions. And then the third thing is, how do I get back to where I was? Like, how do I retrace my steps? How do I get back to a safe starting point? Let's say, don't know about you, but oftentimes, you might be browsing a website and you're like, this is getting too weird. I've configured too many things in this flight search website. I'm just going to go back to the home page and start over, right? So you want to be able to go back to this safe place to restart your search. So these are really, really frequent questions. And especially with question number 3, we can help by providing clear exits, like a back or a quit or some kind of home button, to go back to a starting page. These are things that typically help people a lot. If you think of, again, I'm going to use the versions of iPhone. The original iPhone had this little button beneath the screen. Remember that? And that was great, because you could tell anybody, if you're confused, if something's messed up, hit that button down there. It's the only physical button at the front of this thing. It will take you back to the home screen, and from there on you can find your way, right? If some app is launched and you don't know what it is and you don't know what it's doing, hit the home button once and you're good. Great design, right? Safe place to go back. Clear exit is provided. And then over the years, the home button got overloaded, right? Oh, now I can press it twice to get to, I don't know, the task manager or something. Or if I press it once, it only takes me back one screen, and then press it again, it goes to a different screen. Or if I hold it, it does something else, and then it's like the unlock is on the fingerprint ID. So the home button obviously was so interesting to the designers of the iPhone that it got overloaded with more and more functionality. It's making it less useful as this safe place to go back to, because it doesn't work that way anymore. And then, of course, at some point it got removed, and now it's a gesture, which, yeah, the screen is bigger, which is nice, but from a point of view of usability, not necessarily an improvement. The other part, closed dialogues, refers to something that could be maybe a little difficult to understand, but what it means is when you have a dialogue sequence where you're doing something, let's say you're ordering something, you want to know exactly when you're done, when you've completed that step, right? You want clear feedback that you've wrapped this up. So here's an example of, at the end of a lengthy sort of process of going through ordering something on Amazon, you get, thank you, your order has been placed. In fact, this is what it used to look like. If you do it now, that note isn't quite as prominent anymore. A little bit of a, it's gotten a little less useful than it used to be, or less well designed in terms of clear feedback that you're done with your order. Right? So this is good, though. On the other hand, here's an interesting dialogue that popped up that I thought was entertaining. Connection was lost. Would you like to reconnect? Yes or okay? Don't know what that means. Anyway, moving on to step number 8, including help and documentation. We already mentioned that providing something like a keyboard overlay or a list of shortcuts is a good idea, but providing help and documentation needs to happen on many different levels. So you want to. This is almost like a continuum, right? You have on the one end, you have stuff that is available extremely fast. For example, tooltips, right? That pop up immediately, right? I should be able to turn them off, but I can get to them right, with just for hovering over something, right? I use this a lot. You probably do yourself too. If you have an unfamiliar interface, you use that to explore it on a very lightweight basis. And then something but it can only provide very little content, right? So then you have something like an online help, right? That you can maybe search even, right? Where you can look for stuff. Or like the question mark in a dialogue that you click on, and then you get a little explanation about that dialogue, right? That's more content, not quite as at your fingertips available. And then all the way over here is then things like manuals printed or as PDF or whatever, where you can go there if you really want to know all the in-depth stuff about something because you're struggling with some function, but it's also very remote. It's not as connected to your current task and what you're doing right now. So all these have their own place and are useful and should be available for the user to pick from. But of course, we know the old rule, users don't read manuals. So be aware that while you need to provide it for the users as a whole, there may be users that don't read it, and they still need to be able to somehow use your software. There is a lot of options to make help a little more active. Maybe you've seen this, right? You can sometimes search for a function, and the system will actually show you the menu, will highlight the menu where that function is, right, to show you where you can find it. So that's helpful. But the danger of that is that the system is then taking over the initiative, right? So again, a bit like the popping up, your battery is fully charged kind of thing. You got to be careful that the user can remain in control so that the system doesn't become too unpredictable when the system takes over. And assistants and wizards can be both a blessing and a curse here, right? If I take a user through a certain series of steps, yes, that's very helpful. They don't need to find their own way. But if it's not the way that they wanted to take, then it's like, taking the elderly lady across the street that didn't even want to cross the street in the first place. Now we get to rule number 9, addressing diverse user needs. What does that mean? We used to call this sort of, provide shortcuts for experts. But this is kind of a more inclusive and all-encompassing version of this. Because when somebody is a novice, we talked about this many classes ago, novices need a simple interface, lots of explanations, lots of help, lots of feedback, etc. Whereas people who use the system more frequently will actually want less fussy interaction. Right? They don't want to be receiving all that feedback and all that detail anymore. So on the other hand, they want to speed things up. Right? If you've used the system a lot, you're like, how can I create a keyboard shortcut for this so I don't always have to go to this menu? If you're using an IDE to compile code, and upload it to whatever, your embedded board. You don't want to go through a menu every time to do that. You want a keyboard shortcut to do this quickly, right? So that's something people want. Or macro recording, to be able to do 5 things that you do a lot every time. Like, for example, when I go and pick up my wife from work, then I tend to send her a text, right, that I'm there. And I do this many, many times. So I want a shortcut that I can trigger with a single click, that I don't always have to type the same message again and again. And also, these frequent users will want quick responses that don't overload them with feedback, right? So they want the interface to become a little quieter and a little more sort of professional. Different age ranges also have different interface expectations. Don't fall into the trap that is very, very easy to fall into, which says, okay, so old people are dumb and they don't know how to use technology and they also hate it and they're afraid of it, so we're going to design this thing with big buttons and less functions, because that's not what's going on. Right? You will find sometimes, I know people who, in their 80s, 90s, are happy to use WhatsApp because it keeps them connected with their kids, and on the other hand, but don't want to do online banking because they enjoy going to the bank instead and talking to a couple folks on the way. Right? So it's a much trickier topic than we tend to think. And just as I wouldn't put all you folks into one bag and say, okay, so these are like young people, right? So I know exactly what they need. So don't fall into that same trap and say like, oh, these are old people, so I know exactly what they need. They're just as individual as you are. Just because you are yourself in 50 years, you're not going to suddenly become a gray mass that is all, all the same. So individual needs remain and individual differences remain, no matter what age people are. Yeah.
But doesn't it, like, once you start differentiating that much between different user groups, you will not be as predictable with your system, right? Because every user uses it in a different way and can do different things, and they can't really teach each other well how to use it. And doesn't it make more sense to be like, okay, this is how it would be if the user, like, this is the more optimal way, and then the user just gets trained to do it?
Yeah. Wonderful question, and there is no easy answer. This is design. Sorry. So yes, you want to avoid that people end up having the same system theoretically, but nobody knows how to use it or can share information on how to use it because everybody's system works differently. On the other hand, if you do the one-size-fits-all solution, you're going to make a couple of people quite unhappy. So one of the things that tends to get you out of this conundrum is, as people get more experience with the system, if they have the ability to configure it, if they have for example, configuring shortcuts, right? Maybe even changing shortcuts. Maybe you have used 15 programs that all use the same shortcut for something, and there's a new app that uses a different one. You want to change that, right? But by the time that you get to that point, you are beginning to be a more expert user in this application. So you can probably find your way around it and find the right help if you need it. You're not in the situation anymore of being a beginner who needs very clear instructions. So in a way, the progress of skills in using an app from beginner to intermediate to expert user also means that you become more self-sufficient, and configuring it and customizing it to your own needs can actually be okay, right? Because at that time, if you see an instruction online that says press Control X to do this, you know that you changed that shortcut. Right? So that would be my maybe the careful positive message here, that this is actually not as bad as we might think. So technology affinity, which you could translate as enjoys playing with gadgets, varies widely among people, right? And in this room, we probably are rather on the high side, right? You probably are like, ooh, a new smartphone, cool, let me try this out, right? There's a lot of people who don't get as excited by new smartphones than we do. Just be aware of that. And again, it has little to do with age. Both things are available among the most diverse age groups. While there may be correlations, but they don't mean that everybody above the age of X, wants a phone without features. So addressing diverse user needs is tricky, but it means that you open up a way for people to use your system ever more productively. And so by doing that, you just need to keep the rule 1 in mind, like keeping it simple. If you really are struggling, like you were saying, this conflict, like, you know, different user groups and how do they talk to each other, if you're really struggling, then I would probably rather fail in the direction of, you know, keep it simple. Or you may have to focus on a user group. Right? You may end up saying, okay, this is just for people who, I don't know, have used Emacs all their life as a text editor, right? And you know exactly what kind of shortcuts these people need. Here's an example that I really liked, done years ago by a PhD student at Stanford that I was watching when I was a professor there, and he's now a professor himself. And this is a cool design that he did for a wall display sketching application. And this was a menu that popped up when you used this system with a pen. So imagine yourself, you know, working with a pen on this menu, and then you wanted to, let's say, I don't know, move an item, right? So what you would do, or you wanted to zoom in on something, what you would do is you would basically press a button on this pen, and then this menu would pop up. And then you could do this gesture going out, which would select this, you know, cross this line, would select the item menu, and then items can be moved, highlighted, or zoomed. So this is essentially the second layer of menus. And you go back in through this sector, which selects the zoom option. So you've selected item zoom by doing this gesture, okay? And then it does that. Once you've done that 15 times, you remember that the gesture. And if you do it quickly, the menu doesn't even pop up. So the menu system has somehow turned into a gesture-based system, which is really fluent to use, right? So you sketch something, you press the button, you do a little, you know, sketch gesture, you trigger the command. But if you ever forget about it, all you need to do is hold down that button and have the menu pop up, and you can select it again from the graphical menu. So that's a really nice transition from beginner to expert user, you know, as I learned these gestures. But I can also transition back. Right? If I haven't used the system for half a year, I can just, you know, go back to beginner mode. I don't need to change anything in the interface to do that. Another example, this is the dialog to configure keyboard shortcuts in Mac OS X. So if you are using this, you're already an advanced user of your Mac, right? You're starting to configure your keyboard shortcuts. So this thing is there for, you know, people who are a little more experienced. But the system itself, the actual application to configure this, is still very easy to use. It's designed to be easy to use because while you may be an expert in using your Mac, you are probably, hopefully, not an expert in using this application, right? Hopefully, you're not changing your keyboard shortcuts every Thursday. So that means that even this application, which is for, you know, advanced users of the system as a whole, needs to be beginner-friendly because people aren't going to use this application a lot. And that takes us to rule number 10, which is that we should just be aware of our limitations. And just as you probably wouldn't hire a graphic designer to write your C++ code, the graphic designer probably won't hire you to draw their icons, right? So what I'm showing you here is an icon of a Omni outliner, I think. It's an idea collection, like list manager, basically, on Mac OS. And what you can see here is the icon in different resolutions, in different pixel sizes, right? I want you to notice something. As this thing gets smaller, down to especially this size here, something happens. Do you notice that the blue page is gone in this tiny icon? Why is it gone? Well, because the graphic designer looked at this thing at this pixel size and said, that's a mess if I leave the blue page in there. Nobody can tell that this is supposed to be 2 pages behind each other. So I'm going to remove it so that I at least have a single page image that is still somewhat recognizable. So this is not just Photoshop scaling down, dumb scaling down, but this is actually turning on your brain scaling down and changing a graphic to make it simpler at small resolution so it still is intelligible. People can still read the graphic, basically. And these are kinds of things that you will not easily be doing if you're not trained in this profession. Right?
just as the color selections of these things. I mean, this is a work of art, right? I couldn't draw a light bulb to save my life to look this great. So that's clearly a professional skill. Here, on the other hand, we can see, back to this wonderful page, that not only did this person go crazy with the tab function, but also apparently the only colors they could see for icons were red, yellow, and green, right? Nothing else. So primary colors. Computer scientists love primary colors, right? I don't know. Every time I see an interface, that students design, is always like, yes, 25500. That's a color, right? Full on red, full on blue, full on green. We see that a lot, but those are not great colors to pick, as you know now from your visual design class, right? We can be a little smart about that. If we do pick only these colors, this is kind of the impression we leave, right? Because it looks cheap, right? Cheap is associated with these simple primary colors, childish, so don't go that way. But that's just one example why you don't want to learn all this. You want to hire a graphic designer to do it. So that's the 10 golden rules of interface design. Keep the interface simple, speak the user's language, be consistent and predictable. This was also the stuff with timeouts. Then providing feedback and being responsive based on what we know about Norman's 7 stages. We know feedback is important. And responsiveness is one thing we talk about a little bit more now after this. Minimizing memory load, don't overloading people's short-term or long-term memory. So providing things like help pages, etc., or code pages. Avoiding errors if you can. That's the best way, right? No errors. Helping people to recover from errors if it's impossible to avoid the error situation in the first place. And offering undo as the best way out of a mistake. Just one step back and take a different path. Designing clear exits. I talked about things like the home button and closed dialogues that wrap up clearly the Amazon confirmation, including help and documentation on a whole trajectory here from tooltips to online help to manuals, and addressing diverse user needs both for newcomers and beginners and advanced users that want a more powerful, customizable experience. And then finally, hiring a graphic designer. On to responsiveness and performance. Responsiveness is taken largely from a book by Jeff Johnson, who also wrote a bunch of other nice books. This is a book called GUI Bloopers, which is a wonderful book because it's full of bad user interfaces. So it's a lot of fun to go through and look at until you get to a page where you're like, oh, I did that. I did that same mistake. I made that same mistake. So take a look at this book. And responsiveness is being discussed by Jeff, who's an HCI veteran, as one of the key problems in interactive systems, because bad responsiveness, when a system doesn't answer immediately to your input, opens up the gulf of evaluation, right? At a very fundamental level. When a system doesn't do things the moment I ask it to, then we get confused. A couple of examples. Your mouse cursor lagging behind, or you hit a button and there's an ever so slight delay in the response. Or sliders and scroll bars where you scroll through something and they lag behind, or applications that are saving something and then while they're saving they're dead, right? They can't do anything to do them. Or an app draws its screen and then it draws it again and again, and you can see how it's repainting multiple times. Lots of mistakes of these. There are a couple surprising insights that this is actually a significant issue. Amazon, for example, I got this from Greg Linden at Amazon, reported that they experimented with 100 milliseconds of extra load time of their pages, of the results pages. Okay, 100 milliseconds, a tenth of a second. That caused a 1% drop in sales. That's frightening, right? If you're Amazon, that is not something you want to find yourself at. Google found that 500 milliseconds of extra load time caused 20% fewer searches. This was what Marissa Meyer at Google reported. Yahoo reported 400 milliseconds extra load time caused up to 9% increase in the number of people who clicked back before the page had even loaded. So, this is a big issue. Reasons for poor responsiveness are a lot. First of all, people don't know about it, and they're widely not aware that this is such an issue. If you're a UI designer, you don't think of this, right? Because you mostly think about how do I get from A to B? Is it clear how to navigate through my interface? You don't think about how many milliseconds it's going to take to actually show this new screen. So they also, as designers, they rarely specify performance issues and responsiveness, and then programmers tend to think that responsiveness is the same as performance, and it's not. You can be extremely unresponsive on a modern, gigahertz processor system that is fully loaded, and you can have an extremely snappy experience on a system that runs at 1 megahertz. It doesn't have anything, I would like to say, to do with performance, because there are other factors that really create this responsiveness or unresponsiveness. But it's not easy. It's actually tuning that is difficult, so it's often pushed off to we'll do this in the next release. Another issue that we often run into is that developers who haven't been through DIS1 think of user input just as input from a machine, right? So yeah, it's another pipe, that goes into my program, and I don't care whether it's events from a mouse click or a button click, or whether it's requests from an external data storage service or something like this, right? Well, if the data storage service needs to wait for a response for 100 milliseconds, yeah, they're going to wait. It's going to cost something at some point, but it's not a big deal. But if a user actually, has to wait for these things, their attitude towards the system changes, and they make mistakes, they get frustrated, etc. Well, then there is, we programmers are lazy, right? For a reason. We try to write programs in a way that they are, as easy to write as possible, given all the things that were told to us. So let's say, if we are not told that we need to provide our screen redraw within 10 milliseconds, then we're going to do whatever else we can optimize for, but we're not going to have that on our list of requirements. It's also not easy to measure and to write code for. Most tools that you develop with, even if you run something like Xcode or with instruments in there, on the Mac, for example, or Windows, the Visual Studio environments, they don't provide a lot of tools to check responsiveness, to check how long does it actually take to redraw this thing. So here's a simple example. Scroll bars, okay? Let's say you're implementing a scroll bar. Does text move as you scroll, which is what you want, right? That's the immediate feedback. Or does it only go to the resulting page that you scroll to once you let go, which is bad, right? Well, if the designer of an interface doesn't actually specify this, the developer will choose the solution based on their own decisions and criteria, right? And we know that this will usually be the technically simplest, right? And that's not because the developer is a bad person or wants to build a bad user interface. No, it's because they're not really trained in usability and in particular in the issues of responsiveness. Just as UI designers are not trained in building large software products in C++. So it's quite understandable that the solution will be the technically simplest. If you're lucky, the GUI toolkit supports live scrolling out of the box, and it just works. But if it doesn't, if that needs some extra programming because you need to provide the content in a different way in an asynchronous interface, blah 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 blah, then if the standard code that's in the sample documentation doesn't do this, then you probably won't see that live scrolling in your application if you didn't specify it. So. Responsiveness is not performance. What does that mean? Well, we should realize that processing resources will always be limited, right? It's not that our computers got over the last 20 years probably got 1 million times faster or something like this, right? On this order, you're still looking at an hourglass as much as you do 15 years ago. Right? It hasn't really gotten less. And a lot of people don't realize that the user interfaces are essentially real-time systems that have hard deadlines that need to be met that are based on human cognition, like Bloch's law, for example, right? We know Bloch's law. I think we did this in like, what, first class, right? 100 milliseconds, that's the latest. By that time, most people will see a delay, right? So you want to be well beneath that level. And what people don't realize is that if you have a couple of things to do as developer in your code, and if your application needs to do a couple of things, it doesn't need to do everything right now. Sometimes it doesn't need to do things at all. What do I mean by this? Well, let's say you need to, you're writing a CAD application, right, that to draw CAD files, and the user loads a file, okay? Now the naive implementation goes ahead and loads the file, no matter how big it is, right? How many megabytes or gigabytes of data it is. And when it's done loading, it renders the part of the CAD file that the user is looking at in the starting visualization. But why not just check first which part the user wants to actually see of this CAD file? And once you've loaded that, show it, and then continue loading in the background with the other stuff, right? Or if you look at Google Maps, I mean, they do this, right, for real. If you look at Google Maps, you can see how Google Maps is only loading the part of the map that you're looking at, and then it does some smart prefetching of the neighboring tiles, because it assumes that next you will probably be scrolling off to the right, left, top, bottom, something like that, but it's not loading, you know, the whole map of the whole Earth at full resolution, right? Why would it? And if somebody opens a complex, you know, multi-object CAD drawing and ends up only looking at one part of it and then closes it again, you never had to load the full file, actually, right? If you wrote it in a smart way. So what we're going to do is we're going to take our 100 milliseconds from Bloch's law, and we're going to extend that by 2 additional deadlines. And very conveniently, each of these deadlines is 10 times as long as the one before. So the first deadline is the 100 milliseconds, or 0.1 seconds, right? That's the same, obviously. This is the perception of cause and effect, as we know from the CMN model and Bloch's law. So the delay between me, you know, moving my mouse and the pointer following behind, or between a mouse click and inverting the button. And in fact, I would probably be careful with this first one here, because if you have a mouse pointer that lags behind by 100 milliseconds, that may not confuse you from the time perception, but it's going to create a significant spatial lag, right? You continue to move your mouse, and maybe it's a drawing app, so you're moving your mouse, and your drawing app is lagging behind drawing these things. It's going to look weird, because you get this spatial disconnect. We often see this in touch-based interfaces. When you move your finger, guess why most touch-based apps on your smartphone don't show a cursor under your finger? Because they don't want to show you that they're lagging behind. Right? If they show a cursor, it will always be slightly behind your finger, especially if you make fast movements, and that's going to look weird. So with that, you know, continuous movement, I would be careful. I think we need to be even faster for continuous movement. But for individual things like discrete events, like clicking a button, for example, it's a standard thing. We need to be done within 100 milliseconds for rendering that, well within that. The next deadline Jeff Johnson introduces is 1 second, and that is derived on turn taking in conversations. So if you and I have a discussion and I say something and I stop talking, after about a second, you will react in some way. And even if it's just nodding or going, or maybe starting to speak yourself. If you don't, if you wait much longer than 1 second, it's going to feel off in human conversation, right? So that's why there is this second deadline of this turn taking. This is also, by the way, the minimum reaction time for unexpected events, like you driving down the Autobahn and suddenly, you know, somebody throws a bag of, you know, a water balloon in front of you on the road. You'll be like, ooh, you know, that's the minimum reaction time you have for unexpected events. Remember, 240 milliseconds, if I know I'm waiting for that light to turn on and press a button, right? That's a different story. But if it's unexpected, It's more like a second. This 1 second, because this is the time we give our environment, so to say, or other people, to react to what we're doing, is the maximum time you have to, for example, either open a window that the user opened, or if you can't open the window by that time, start at least showing a progress indicator, a spinning hourglass, or the spinning pizza of death from macOS, or a progress bar, something like that. So this is the 1 second limit. Notice the difference, right? If I press a button to open a file, the button needs to invert within 100 milliseconds, well within 100 milliseconds, so that it feels realistic. And then I can load the file, and if I can do all that within 1 second, I don't need to do anything less. But if there's any chance that this could take longer than 1 second, I need to make sure that within 1 second, the system does more than just invert the button. It gives me some feedback that the process has started, that it is loading the file. And the third deadline is 10 seconds. This is the typical human sort of focused attention span. What do we mean by this? Well, let's say you are you're entering a check into a banking program, like you're entering data into a banking program for transferring some money, or you're completing one step of some kind of wizard to install some software. This should be the maximum time this one step takes. If it takes much longer, then people will start losing their focused attention on this. This is also the maximum time to finish giving input for a task. So, for example, if somebody selects print, until they send off the print job, there should be a way where this usually can be done within 10 seconds. Otherwise, it's too long, and they start losing interest in this. Another thing, what this also means is, if something takes longer than that, longer than these 10 seconds, let's say you're loading a file, and the loading of the file, downloading a large file takes, 30 seconds. After 10 seconds, people will no longer look at that load button anymore, that loading bar anymore. They will be going over and check their status on Facebook or something. So that means that you lost their interest, you lost their focus. And once you're done loading the file, you need to get their focus back, and you need to bring them back into the task, and they need to understand where they are now, that the file has been downloaded, that it's done. They need an alert that it's completed. They need to understand where it now is. They may have forgotten what file exactly they were downloading. All these kinds of things, you need to remap context if things take much longer. So how can we design for this? Well, first thing is you want to meet these human time deadlines, right? So you understand the differences between these three deadlines, and you rely on making sure that these are being met. So that means acknowledging user input immediately. That's the inverted button, right? And busy or progress indicators popping up after 1 second, the latest. The trick is you don't always know when something could take longer, right? I actually once was trying to open a file over a slow connection on a remote server on my Mac, and the system seemed to completely hang for like seconds. Nothing was happening. And then it just popped up the file window. Obviously, somebody wrote these routines thinking that, oh, those files are always going to be on a local hard disk, so I'm going to have them loaded. At least the listing of the files is going to be loaded within fractions of seconds. So why bother with a progress indicator? I don't need one. Well, they were wrong. Right? So be aware that something could be happening over the network and then take much longer than you think. So with the progress bar, we now understand, also from the rule that where we showed the example of the Windows 2000 progress bar, you want to make it real so that it actually advances linearly and not non-linearly. You want to also, does anybody understand why there are always progress bars that, these progress bars that like installing program, and that, let's say it's a progress bar that advances linearly, and then it's done, and then it goes away, and a new progress bar appears, finishing installation. I'm like, why, right? I want to see the total task as a progress bar, because I don't care when you're done with one task. I know it's easier to write it that way as a programmer, but it's not what I'm interested in. So it has to be overall progress and estimated total time remaining. Yeah, no hanging at 99%. We talked about this already. they should be advancing roughly linearly. That's the joke of the Windows user driving home and calling his wife saying like, oh honey, I'm going to be home in 10 minutes. Oh no, 8 hours. No, wait, 3 days. Oh no, it's going to be 5 seconds. Right? That's the typical behavior that we sometimes see from these progress bars, jumping wildly back and forth between these different estimates. Yeah, if we do estimate times and we have a reasonable estimate, then we should make sure that we don't significantly underestimate, but rather overestimate, and use terms that are a little bit more vague to be honest about how exactly we can predict this, and also because people don't really care about individual second estimates. So this is all pretty obvious, but there's actually this is a lot about programming, smart programming, writing code in a way that it's written in a smart way. So for example, has anybody seen the clock on the X Windows system at some point? X Windows often is still the graphical user interface on Linux systems, and under X, the Windows system that we talk about at length, by the way, in DIS2, there is a clock. And this clock is actually being drawn in an interesting order. It actually, I think we have an animation for this. Let me see here. Yeah, it's going to come up here. So I'm going to show you this. So the first thing that the X clock draws is the hour hand, and then it draws the minute hand. And then it puts a couple markers around this, and only once these are there, it puts the individual lines in place. So even if it's extremely slow drawing, because it's, I don't know, drawing over a VNC connection to a remote computer or something, the first thing that's there already tells me that it's somewhere between 12 and 1 o'clock, right? And once the 2 here are there, I know it's roughly 1:45. All the other stuff is extra, extra frills and decoration that are not as essential. So see how the developer of the clock must have thought this through and thought about, what do I need to paint first so that I get the important information across as quickly as possible? So that's what I mean by displaying information, important information first. The second thing you can do is working in parallel. So work that isn't time critical, you can move to a background process. For example, let's say you're loading a long Word document, right? And you want to, I don't know, make sure that this is formatted properly or something, or insert the spell checking wiggly underlines. You don't need to do that for the entire document at the beginning before you show the first page, right? You can show the first page and then continue with the spell checking on the rest of the document in the background. And as I explained earlier with Google Maps, work ahead by preparing likely requests. Right? If you know what's probably going to be asked next, it's a really good idea to simply do that already while you're waiting for user input. Wonderful example here. I think by now more and more browsers have been picking this up. But you know how normally when you download a file, you say download the file, and then a dialog pops up and asks you where to save it, and you say where to save it, and then it downloads, right? Years ago, Opera did it differently. You said download this file. They popped up the dialog asking you where you want to put it. And while you were making up your mind where you're going to put it and navigating through folders and picking a destination, it was already downloading the file to a temp file somewhere in the Scratch directory. So by the time you'd made up your mind where you put it and you said, yeah, put it here, oftentimes the download was mostly done. And you're like, wow, Opera is so fast. How are they doing it, right? It's simply by being smart and not wasting time with the computer twiddling its thumbs while it's waiting for your input. It can do something useful in that time. This is also an example of queuing things optimally, right? So thinking about what are the tasks that need to be done, and how can I sort these in a way so that they happen in the most responsive way for the user that sees things immediately. I've got another example here that shows this in an extreme case. So none of you, hopefully, used this software ever. I haven't used it myself. It's just from the history books. It's called WordStar. It used to be a word editor before Microsoft Word started taking over. And WordStar was running on amazingly slow computers back in the day, right? But WordStar was really known for never losing a character you typed. And I don't know about you, I actually have encountered recently, you know, every now and then you encounter an application that actually cannot keep up with your typing, which is ridiculous, right? I'm typing a couple characters a second. That shouldn't be hard to process, but you know, this system was never losing a character. How were they doing it? Well, they changed the strategy. If they noticed that they weren't able to keep up, they decreased other tasks. For example, imagine this running on a 1 megahertz computer, right? So the way they did it was whenever you were typing something, it was always being rendered on screen instantly. So any character you typed always was top priority to render. If the computer couldn't keep up, then it would sometimes stop updating like the top and bottom of the screen. You can't see it in this picture here, but it would sometimes, you know, not update the top and bottom of the screen because that was considered to be the periphery of where you're not, which is not as important as, you know, putting out the characters you were just typing. So the other thing is testing under different conditions, right? Testing your, if you write software and you're testing it only on your own computer in your lab with, you know, a high-speed internet connection, that may not be realistic, right? So this is more realistic, right? You know, this kind of reception situation. Does your software still do something useful then? Nobody's asking you to magically, you know, create speed where there is none, but it should do something that tells the user what's going on. So Amazon, for example, for the longest time, still tested their website on outdated browsers on 56K modems. I don't know if you guys have ever seen a modem, but yeah, okay. And you know, imagine this, right? So you need to think about what are the net connections, the systems that our customers have, and on those systems it has to run properly. Finally, a word on latency to wrap this up. We've discussed the 100 milliseconds that can pass at maximum between, you know, when it starts feeling off, right? So we want to make sure that when you, I don't know, click a button on a gamepad or a joystick or in a mouse or in a keyboard until something happens on the screen, that needs to be well within 100 milliseconds, right? Well, guess what? On modern computers, that's often not the case. And this is something that I really just discovered last year, and it really surprised me. On modern systems, you will find that actually LCD screens, for example, I mean, gamers know this, right? LCD screens add several dozens of milliseconds of lag, because unlike CRTs, like, you know, TVs and old school monitors back in the day, you know, an LCD will have to wait for essentially for the entire picture to arrive and then show it in its LCD matrix. And a CRT, you know, what do you call it in German? In Kathodenstrahl monitor, like a big clunky old TV, the things that your parents are throwing away now. That didn't store the image, right? It was just paint the image as you were sending it there, line by line. So there was no delay between a pixel being sent to the image and it being displayed. Nearly no delay. Maximum was maybe 20 milliseconds, which is, you know, fine. Never more than that. So LCDs have more delay than that. And it's roughly around, you know, depends on the model, of course. Sometimes it's just you know, 20, 30 milliseconds. Sometimes it's as much as 80, 100 milliseconds delay. So that already means that your display is actually on a modern computer, oftentimes introducing a latency that is messing with your overall end-to-end system latency. And here's the second thing, and that's really frightening. USB, as you know, probably is a polling protocol, right? So in USB, the computer is asking the device, you know, so what's up? Right? And then the device says, okay, I got a new mouse click to report, right? Or something like that. Now, if you get a standard simple USB device, low power USB device, they often run at 125 hertz, meaning that it's only asking sorry, not 125 hertz. It runs at 125 milliseconds polling interval. Sorry. So meaning that it's only asking, what, like 8 times a second, whether there's any new data. Right? So what that means is, and we measured this, you can actually, if you connect a cheap USB input device, like, I don't know, like a gaming joystick or something to a computer, you will actually see from the moment you close that button, which you can electrically, determine that moment with a circuit, to the moment that actually arrives in the computer can take up to 125 milliseconds. And not only that, but the time that it takes to get there is actually going to be varying. Sometimes it's there almost immediately because you happen to hit the moment when the poll happens. Sometimes it's going to take 125 milliseconds. Guess what that does with your gaming performance? Because there's no longer a way to jump, make Mario jump right at the edge of that, cliff to make it across the ravine, because sometimes you're going to be too late, sometimes you're going to be too early, and you can't really train or predict it. So that's terrible, right? That's why pro gamers actually get out their cathode ray tube TVs and play on these monitors. That's why these monitors are, so if your parents are throwing theirs away, tell them to sell it on eBay instead. It can make good money right now. And they also tend to not use these devices. They carefully pick input devices that don't have that kind of delay. Sometimes you're better off using a 16 megahertz Arduino, like a super slow Arduino, where you can connect your button directly to an input pin because it can react that very moment, the next processor cycle when that button gets closed, as opposed to USB, which first needs to make up its mind on what packet to send down the line and then wait for it to be asked, et cetera, et cetera. If you want to know more about this, I've got some materials at this URL/latency here on our homepage. All right, we're going to wrap this up because we still need a few minutes for class evaluation. We're going to do that at the end of the class here today. So what we talked about today were the 10 golden rules. I'm not going to read those again. And we talked a bit about responsiveness. You saw the 3 human deadlines by Jeff Johnson and how to work, how to write smart code so that these deadlines are being kept. And we also mentioned latency a little bit. Next week, we're going to talk mostly about notations. And I want to give you an overview of what we've done in this class this semester. You may remember this, right? This was the roadmap of the class. So since it's an introduction to human-computer interaction and designing interactive systems, we talked about the human a lot. You learned models of how humans perform, CMN model. We talked about affordances, mappings, constraints, external, internal knowledge, etc. Knowledge in the world, knowledge in the head, how people make mistakes. And we wrapped this up with the class on visual design. 7 stages of action, all that kind of stuff. Then we went to the case studies where we looked at systems out in the world, how HCI evolved over the generations, right? So we saw a couple seminal systems in this space. We talked about some visions of the past, of the future, and how these became true or not. And we looked briefly at these Baroque phases of technology, etc. And in the third part, we had this development process. This was probably the, in practical use, when you do usability, you can answer a couple questions with this, right? Knowing how humans think and how much they can remember and blah, 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 and Gestalt laws, etc. But most of the stuff will depend on the current context, user, and task. And so we gave you tools to work out how to find answers to those questions in a usability project. What we're going to do next week is we're going to wrap this up by giving you some ways to write down interaction designs, to specify them in a mathematically sort of reliable way so that you can pass them on to a development team and they know what kind of things they have to implement and what kind of requirements you have.
This content was provided by RWTH Aachen University.